Hi, this is Rajnikant Mishra. Today we are going to discuss the derivation of the formula for the volume and surface area of the sphere. But before it, let's take a quick view on the previous lecture in which we discussed the derivation of the formulas of surface area and volume of a cylinder and cone. The link of that video is given in the description box. Now, the volume of the sphere. In this figure, this is the thin circular disc. O is the center of the sphere. R is the radius of the sphere. Y is the distance of this circular plate from the center O. X is the radius of this thin circular plate. The width of this thin circular plate is dy. This is your x-axis. This is your y-axis. Here O represents the point of origin. So the limit of this sphere is minus r to plus r. Since this disc is very thin, so it's like a cylinder. The volume of this cylinder is the base area into height. Base area is pi r square and height is dy. So the small volume dv is equal to pi x square into dy. Here this x is the radius of this thin plate. Now apply Pythagorean theorem in right angle triangle OBA. Y square plus x square is equal to r square. R is hypotenuse of triangle OBA. So we can write x square is equal to r square minus y square. Put this value of x square in this formula. So dv is equal to pi r square minus y square into dy. Now we have to find the volume of whole sphere. For it, we have to add the volumes of all such plates from minus r to r. Here we use the concept of integration. Integrate both sides with limits minus r to r. dv is equal to integration minus r to r pi r square minus y square dy. Here pi is the constant, so take it out. Integration of r square dy is equal to r square y. Integration of y square dy is equal to y cube by 3. So v is equal to pi into r square y minus y cube by 3, limit minus r to r. Here v is the volume of whole sphere. Now first put y is equal to plus r and then y is equal to minus r. V is equal to pi r cube minus r cube by 3 minus, put y is equal to minus r cube minus r cube by 3. This minus is equal to plus. This minus plus and plus minus means r cube by 3. R cube plus r cube is equal to 2r cube. Minus r cube by 3 minus r cube by 3 is equal to 2r cube by 3. 2r cube common, 1 minus 1 by 3 is equal to 1 minus 1 by 3 is equal to 2 by 3. 2 by 3 into 2 is equal to 4 by 3 r cube. So we can say v is equal to 4 by 3 pi r cube. This is the formula for the volume of a sphere. Now we are going to derive the formula for the surface area of the sphere. There is a circle of radius r, who is the center of the circle. An arc AB subtends an angle of theta radian at the center of the circle. Then the length of arc AB is equal to r theta. Here r is the radius of the circle and theta is in radian. Now in main figure, angle AOB is equal to theta radian. OA is equal to x, which is the radius of this thin plate. So in right angle triangle OAB, OA is equal to x is equal to r cos theta, because cos theta is equal to x by OB, which is r. Here the surface of this thin plate is little bit curved, so it acts as an arc. Let this small arc subtend a very small angle d theta at center O. Then the width of this strip is equal to r into d theta according to this formula. By angle, the limit of this sphere is from minus pi by 2 radian to pi by 2 radian. The curved surface area or the lateral surface area of this cylindrical strip is equal to the circumference of this circle into width dy. ds is equal to 2 pi x into dy. 2 pi x the circumference of this circle, where x is the radius of this circle, dy is the width. Put the value of dy, ds is equal to 2 pi r cos theta into r d theta, because x is equal to r cos theta and dy is equal to r d theta. So ds is equal to 2 pi r square cos theta d theta. Now to find the total surface area of the sphere, we have to add the lateral surface areas of all these strips from this point to this point. Here we use integration concept. Let integrate both sides from limit minus pi by 2 to pi by 2. Integration of ds is equal to integration of 2 pi r square cos theta d theta with limit minus pi by 2 to pi by 2. Here 2 pi r square is a constant with respect to d theta, so take it out. The integration of cos theta is equal to sin theta. So the total surface area of this sphere S is equal to 2 pi r square into sin theta, limit minus pi by 2 to pi by 2. First put theta is equal to pi by 2, then theta is equal to minus pi by 2. Sin pi by 2 is in first quadrant, so sin pi by 2 is equal to 1. Minus pi by 2 is in fourth quadrant, and we know in fourth quadrant sin theta is negative, so sin minus pi by 2 is equal to minus 1. Now S is equal to 2 pi r square into 1 minus minus 1. Minus into minus is equal to plus. 1 plus 1 is equal to 2. So the final formula is S is equal to 4 pi r square. This is the formula for the surface area of the sphere. Here is a very interesting concept. A sphere is inscribed in a cylinder. The radius of this sphere is r and the height of this cylinder is 2r. In this case, the lateral surface area of this cylinder is 2 pi r into height h. 2 pi r h. Put the value of h is equal to 2r. The lateral surface area of the cylinder is equal to 4 pi r square. So in this case, we can say the total surface area of the sphere is equal to lateral surface area of the cylinder. The homework problem. The radius of both these spheres is equal to r. In first case, a cylinder of largest volume is inscribed in a sphere, and in second case, a cone of largest volume is inscribed in a sphere. If the volume of this cylinder is V1 and the volume of this cone is V2, then find the ratio between V1 and V2. The solution of this problem will be discussed in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update. Thank you.